Well, in last video, we derived an expression for the energy of electron in the stationary orbit of hydrogen-like atom, and also the energy of electron specifically in the Bohr's orbit of hydrogen atom. And hence, we already know the expression, and the expression for the energy of electron is given by E will be equal to minus mz square e power 4 by 8 epsilon naught square n square h square is the expression for the energy of electron. So, ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ನಲ್ಲಿ ನೆಗೆಟಿವ್ ಬಂದ್ಬಿಟ್ಟಿದೆ, ಮೈನಸ್ ಎಮ್ ಝೆಡ್ ಸ್ಕ್ವೇರ್ ಇ ಪವರ್ 4 ಬೈ 8 ಎಪ್ಸಲಾನ್ ನಾಟ್ ಸ್ಕ್ವೇರ್ ಎನ್ ಸ್ಕ್ವೇರ್ ಹೆಚ್ ಸ್ಕ್ವೇರ್. ವಾಟ್ ಡಸ್ ದ ನೆಗೆಟಿವ್ ಸೈನ್ ಸಿಗ್ನಿಫೈ? ಈ ನೆಗೆಟಿವ್ ಸೈನ್ ಯಾಕೆ ಬಂದಿದೆ, ಅದರ ಅರ್ಥ ಏನು ಅಂತ. The negative sign, here you see in the expression, n is in the denominator. n denominator ಇದೆ. Naturally, as n increases, e should also increase. ಯಾಕೆಂದರೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಇದೆ. If there would have been a positive sign, then increase in n would have resulted in decrease in E, but the expression contains negative sign, and therefore increase in n also results in the increase in the energy of the electron. ಅಂದರೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಅರ್ಥ ಏನು ಅಂದರೆ, ಕ್ಲೋಸರ್ ಆರ್ಬಿಟ್ಸಲ್ಲಿ ಅಥವಾ ಲೋಯರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಸಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿ ಕಡಿಮೆ ಇರುತ್ತೆ. ಹೈಯರ್ ಆರ್ಬಿಟ್ಸಲ್ಲಿ, ಹೈಯರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಸಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ದಟ್ ಈಸ್ ಒನ್ ಇಂಪಾರ್ಟೆಂಟ್ ನೋಟ್ ದಟ್ ಯು ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಸೊ ಎನರ್ಜಿ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ increases with the increase in the principal quantum number. So one of the note that you should remember. So now I will consider the expression E is equal to minus m z square e power 4 divided by 8 epsilon naught square n square h square. I consider this expression. Here in this expression, for hydrogen atom, Z will be naturally 1, and for first Bohr orbit, n should be taken 1. So Z ಮತ್ತು n values ನ 1 each ಇಲ್ಲಿ substitute ಮಾಡೋಣ. Therefore, energy of electron will be minus m means mass of the electron, that is a well-known constant value. Hydrogen atom ತಗೊಂಡಿದ್ದೀವಿ, ಅದಕ್ಕೋಸ್ಕರ Z1 ತಗೊಳ್ತೀನಿ. E is the charge of the electron, and you all know what is the charge of the electron. It is 1.6 into 10 power minus 19 coulomb. And then the denominator 8 as it is. Epsilon naught is a constant, and you know the value of epsilon naught. absolute permittivity of free space, and this is square. N is taken as 1 because you have taken the first orbit, and h is a Planck's constant, you know, it is 6.625 into 10 power minus 34 joule second. So the whole square I will. I will simplify that. You will get the energy of the electron in the first Bohr orbit of hydrogen atom, which will be in joule. So energy joule in birth. But customary practice now energy in joule we will express it in electron volt. So electron volt ಹೇಗೆ ನೀವು ಕನ್ವರ್ಟ್ ಮಾಡೋದು ಈ ಫ್ಯಾಕ್ಟರ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿಬಿಟ್ರೆ you will get this is power 4, this is power 4, and you divide by 1.6 into 10 power minus 19, you will get the energy in the unit electron volt. On simplification, this is a constant. You need to bear this. This is approximately minus 13.6 electron volt. So ಹಾಗಾಗಿ ನಾವೆಲ್ಲ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಬೇಕು. Energy of electron in first Bohr orbit of hydrogen atom is minus 13.6 electron volt. So this is a very, very important constant that you need to bear. And the next concept that you need to know, energy of electron in other Bohr's orbit of hydrogen-like atom. So if the atom is hydrogen-like, then E will be, you know, Z is taken 1 here, N is taken 1. So excluding Z and N, you get the same constant. So minus 13.6. E is a constant, and what else is remaining? Z square by N square is remaining. So this gives you the energy of the electron in other Bohr's orbit of hydrogen-like atom. So helium atom, singly ionized, doubly ionized lithium atom, ಇಂಥದಕ್ಕೆಲ್ಲ ಎನರ್ಜಿಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನು ಅಂತಂದರೆ minus m z square e power 4 divided by 8 epsilon naught square n square h square can be reduced to the form minus 13.6 into z square by n square. So this is how you will evaluate the energy of the electron in Bohr's orbit of hydrogen and hydrogen-like atom. These are very, very important constants. You need to memorize these constants. Now we shall discuss about hydrogen spectrum. Now as you see in the diagram, you have considered a hydrogen atom or hydrogen-like atom. That means the atom will have single electron, and that single electron occupies ground state of the atom. So ground state on the first orbit. You know there are many rules that will help you in assigning the orbits for the electrons. Hund's rule of maximum multiplexity, Pauli's exclusion principle, Hoffman's rule ಅಂತ ಎಷ್ಟೊಂದು ರೂಲ್ಗಳಿದೆ. ಆ ರೂಲ್ಗಳೆಲ್ಲ ನಿಮಗೆ ಯಾವ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವ್ಯಾವ ಆರ್ಬಿಟಲ್ಲಿ ಪೇರಿಂಗ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಎಲ್ಲೆಲ್ಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ತಿಳಿಸೋ ಅಂಥ ರೂಲ್ಗಳು. ದಟ್ ಈಸ್ taught to you more in chemistry classes. So now there is a single electron, and the single electron will occupy the least energy state, that is the first orbit of the atom. And that electron will have constant energy. That electron will be orbiting around the nucleus in stationary orbit. But if you excite this electron, that means if you give an electron the energy, so if you electron will excite h new energy ಕೊಟ್ಟು, then the electron absorbs energy and it takes transition to higher orbits. Electron will take transition to higher orbits, and the transition depends on the energy that you give. ಸೊ ನೀವು ಎಷ್ಟು ಎನರ್ಜಿ ಕೊಡ್ತೀರೋ ಅದರ ಮೇಲೆ ಅದು ಯಾವ ಆರ್ಬಿಟಿಗೆ ಹೋಗಬೇಕು ಅನ್ನೋದು ಡಿಸೈಡ್ ಮಾಡುತ್ತೆ. And these energy levels are unstable. Electrons are highly unstable in higher energy levels. And the electron in a very short span of time will get de-excited. ಮತ್ತೆ ಅದು ತನ್ನ ಇನಿಷಿಯಲ್ ಆರ್ಬಿಟ್ಸ್ಗೆ ವಾಪಸ್ ಬರುತ್ತೆ. And when the electron gets de-excited, the electron will emit radiations which are electromagnetic radiations. So de-excite ಆದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ electromagnetic radiations ಮತ್ತೆ re-emit ಮಾಡುತ್ತೆ. And this series of electromagnetic radiations that is emitted by the electron when it gets de-excited will be called as hydrogen spectrum. So ಇದನ್ನು ನಾವು hydrogen spectrum ಅಂತ ಕರಿತೀವಿ. Now let us say E2 as the energy E2 is the electron energy in some higher energy level, or let us say 2, 3 or 4 or 5 or something like that. And E1 be the energy in some lower energy level. So E2 is the energy of the electron in higher energy level. E1 is the energy of electron in some lower energy level. So during de-excitation of electron, you know, when the electron gets de-excited, it emits electromagnetic radiations. And what is the energy of the electromagnetic radiations? Energy of radiation emitted. Will be given by the difference of the energies of electrons in higher and lower energy levels respectively. Now you know what is the expression for energy of the electron in the stationary orbit. It is minus m z square e power 4 by 8 epsilon naught square n square h square. So ಇದು higher energy level ಆಗಿದೆ. To differentiate higher and lower energy levels, I will put n2 here, minus of minus mz square e power 4 by 8 epsilon naught square n1 square h square, where n1 is the lower energy level. Now among these two I shall take out mz square e power 4 common factor. In the numerator, 8 epsilon naught square h square as a common factor in the denominator. Now what am I left with? Minus 1 by n2 square plus 1 by n1 square. Therefore, I will write 1 by n1 square minus 1 by n2 square. By Planck's hypothesis, you all know E will be given by hc by lambda. Energy of the radiation will be given by hc by lambda. Therefore, I substitute for E here. hc by lambda is equal to mz square e power 4 by 8 epsilon naught square h square into 1 by n1 square minus 1 by n2 square, like this. I have substituted for E in terms of lambda. So now I retain 1 by lambda here and multiply hc with this factor 8 epsilon naught square h square. Now I get 8 epsilon naught square ch cube. Now connect the hydrogen spectrum. So ಅದಕ್ಕೆ z ನ ನಾನು 1 ತಗೊಳ್ತೀನಿ. z1 ತಗೊಂಡು ಮಿಕ್ಕಿದೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಇವಾಗ z1 ಬಿಟ್ಟು ಮಿಕ್ಕಿದೆಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಇರೋದು. mu e 8 epsilon naught c h ಎಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಇರೋದು. z2 1 ಹಾಕ್ಕೊಂಡ್ರೆ ನಾನು is a constant for hydrogen atom and it is called Rydberg's constant. We denote it by R. So R represents Rydberg's constant and R is equal to mz square e power 4 divided by 8 epsilon naught square ch cube. Therefore, what do you get? Therefore, 1 by lambda will be equal to R into 1 by n1 square minus 1 by n2 square. What is lambda? Wavelength of the radiation emitted due to the excitation of electron. 1 by lambda. It is called wave number. It is represented by u bar. What is this wave number? What does it mean? Wave number means the number of waves that you can accommodate, electromagnetic waves that you can accommodate in 1 meter length. So 1 meter length and ಎಷ್ಟು electromagnetic waves ಅನ್ನು ನೀವು accommodate ಮಾಡಬಹುದು, ಅದು wave number. So I will say it is the number of waves in 1 meter distance. Therefore, you can also write 1 by lambda as the wave number R into 1 by n1 square minus 1 by n2 square. So this is the expression for the wave number of the electromagnetic radiations of the hydrogen spectrum when the electron gets de-excited from higher orbit to the lower orbit. So this is the expression. So R is called the Rydberg's constant. You remember R will be equal to, on simplification, mz square e power 4 by 8 epsilon naught square ch cube na ನೀವು z value 1 ಹಾಕೊಂಡು simplify ಮಾಡಿದ್ರೆ you will get the result as 1.097 into 10 power 7 per meter. 1.097 into 10 power 7 per meter is the value of Rydberg's constant. So you all remember that. So ಬೇಕಾದರೆ ಇಲ್ಲೆಲ್ಲಾದರೂ ಒಂದು ಕಡೆ ಬರೆದು ಬಿಟ್ಟರೆ ಇನ್ನೂ ಒಳ್ಳೆಯದು. So Rydberg constant is 1.097 into 10 power 7 per meter. Approximately, you will all remember that value. So this is about hydrogen spectrum's wave number. So wave number ಗೆ expression ನ derive ಮಾಡಿದೆ.